Hello everyone. Now today we are going to do the chapter 2, encoding schemes and number system. Whenever we are typing anything, we are typing in high level language, that is English like language, but computer is a machine. Machine can understand only the language of on and off, that is 0 and 1. 0 is off, 1 is on. So here, have you ever thought how the keys on the computer keyboard that are in human recognized form are interpreted by the computer system? This section briefly discusses text interpretation by the computer. We have learned in the previous chapters that computer understands only binary language of zeros and ones. Therefore, when a key on a keyboard is pressed, it is internally mapped to a unique code which is further converted to binary. When a key A is pressed, it is internally mapped to a decimal value 65 code value, which is then converted to its equivalent binary value for the computer to understand. So here you can see when we are typing A, actually it is the code equivalent is 65, and the machine can understand only the language of on and off, that is 0 and 1. So in binary language we are converting it into 65, and internally the CPU is using this for processing. Same way all the Hindi alphabets from Hindi keyboard, like A is 905. So this is the hexadecimal value of A, that is our Hindi language. So same way you can see in this tables also it is given. Now previously we were using only American Standard Code for information interchange, ASCII codes we were using. So these were our ASCII codes. Even now when we are printing our alphabetical patterns, we are using 65 for capital A, 66 for capital B, and so on till 90 is for capital Z, and 97 is for small a, like this, till 121 is for small z. Same way for all the different other characters we are having the decimal values. So if you are asked to convert data into, you have to encode the word data. Now you can see here D is 65, A is 6, D is 68, A is 65, then data T is having some value, again A is 65. So here you can see how to decode it. So in this, D is 68, A is 65, T is 684, and A is 65. So this is your ASCII conversions. So internally like this it is functioning. Now here you can see all the 7-bit binary code of all the ASCII codes. Now ASCII was Indian script code for information interchange. This was for Indian languages, all the Indian languages. Now next is our Unicode. There were many encoding schemes for character set of different languages, but they were not able to communicate with each other, as each of them represented characters in their own way. Hence, text created using one encoding scheme was not recognized by another machine using different encoding scheme. Therefore, a standard called Unicode has been developed to incorporate all the characters of every written language of the world. Unicode provides a unique number for every character irrespective of device, server, desktop, mobile, operating system, Linux, Windows, iOS, or software applications. Clear? So this Unicode is, in this all the languages can be converted from one form to another. Commonly used Unicode encodings are UTF-8, UTF-16, UTF-32. It is a superset of ASCII, and the values 0 to 128 have the same character as in ASCII. Unicode characters for Devanagari script is shown here. Each cell of the table contains a character along with its equivalent hexadecimal value. So here you can see the Unicode of the Devanagari scripts. Now the different number systems. So now we are going to do all the 4 number systems, which are the most important thing. That is our binary, our decimal, octal, and hexadecimal. So here you have already seen how all the characters are converted into machine language. So these number system for computers. Now this is very important. So in binary, bi means 2, nari is number, base is 2 comprises only 0 and 1. So this is our machine language or low level language, where the language of on and off, that is on means 1, off is 0. Now next is our decimal, which we have learned till now in maths, where base is 10. So 10 digits from 0 to 9 we are using. Next, octal base is 10, 8 digits from 0 to 7. Then hexadecimal base is 16, 16 digits from 0 to 15, where 0 to 9 we are writing. After that 10, for 10 we will write A, for 11 we will write B, and for so on. For 15 we will write F. So this is our hexadecimal number system. Now you can see here how it goes on. After 0 and 1, you might have seen the speedometer of your vehicle, or in the petrol pump you have seen the wheels rotating, how it rotates from after 0 and 1. What happens here? 1 will come, and this will again start from 0 and 1. Then again like this, here 1 will come, again this will start from 0 and 1, then it will give a carry. So here 1 carry it is giving, passing on. So like this it is functioning. Next is our decimal number system, which you all know. After 9, then 10 will come. Like here after 1, then it is changing, combination of 10 is coming. Here after 9, 10 is coming. In octal, till 7, 8 digits from 0 to 7. After that, for 8 you are writing 10, and then again from 0 to 7, then 20, 0 to 7, and so on. For hexadecimal it is 0 to 9, and for 10 to 15 we are using these alphabets. After that again 10, and these codes will again be repeated. So now conversion from one unit to another unit also we have to learn. So let us see here how it is. Now here the 4 number system, base already we have seen. For binary it is 2, decimal it is 10, octal 8, and hexadecimal 16. So here first one by one we will see. So here you can see the decimal number system. If 123.45 we have given. Now you can see here, if the decimal point is here, the positional numbers we have to see. Positional number means right to left for integer and left to right for the fractional part. So here 0, 1, 2 and so on, and positional value will be, if it is a decimal number, 10 to the power 0, 10 to the power 1, 10 to the power 2, that is we will write the position. And if it is, here we are using decimal, if it is an octal number it will be 8 to the power 0, 8 to the power 1 and so on. If it is a binary number we will write 2 to the power 0, 2 to the power 1, 2 to the power 2 and so on. So here it is very easy to find out. 1 into 10 to the power 2 is 100, then 2 into 10 to the power 1 is 20, 3 into 10 to the power 0 is 3. So it is 123. Same way here, minus 1, minus 2, minus 3 and so on. So 10 to the power minus 1 is 1 upon 10 is 0.1. So here into 4 will be 0.4, and this will be 1 upon 100 means 0.01, into 5 will be 0.05. So when you will add it, you will get 123.45. So this is your decimal number system, where base is 10 and the digits 0 to 9 we are using. Same thing they have shown here. This is the integer part. If it is 237, we are writing it like this: 200 plus 30 plus 7. And if it is fractional part, then we are writing 10 to the power minus 1, 10 to the power minus 2. So we are getting the result as 237.25. If it is a binary number, then what we are doing is, here this we have already seen, that is from 0 to 9 all the binary equivalent we have already seen, and in this also the base will be 2, that is the 2 digits we are using, 0 and 1. So this is our machine language. In octal number system we are having 8, base is 8, and from 0 to 7. So here you can see octal numbers from 0 to 7. Decimal is same. In binary 3 bits we are using to represent these octals. So from 000 to last 7 is 111. Next is hexadecimal, 16 numbers are there from 0 to 9 and A to F. So total 15 numbers, 0 to 15 you can see here. So 0 to 9 and A to F, and base is 16. So here you can see 0 means all 0, so same decimal equivalent. And here after 9 you can see here for 10 we have written A, like this 15 will be F, and 15 means all 4 ones. So here when you are converting hexadecimal to binary, then 4 bits we have to use. So now the applications where we are using it, you have seen machine understands the binary language. Now and sometimes for colors also we are using all the hexadecimal equivalents. So all the colors representation is given here. Now conversion from one system to another. Now here these conversion from decimal to other number system. So whenever any decimal number is given to you, what you have to do, only 4 steps. We will divide the number by the base value of the number system in which it is to be converted. If it is to be converted into binary, we will divide by 2. If it is to be converted to octal, we will divide it by 8, and if it is to be converted to hexadecimal, we will divide it by 16. Now we will note down all the remainders. Keep on dividing the quotient by the base value and note the remainder till the quotient is 0. So till your quotient becomes 0, we will keep on dividing it. Write the noted remainders in the reverse order, that is from bottom to top. So these 4 steps are the most important part. So here these 4 steps. So any decimal number can be converted into any other number system. Now first we will start with decimal to binary conversion. Suppose the question given is 65, so we will divide it by 2. 2 3 the 6, 2 to the 4, remainder is 1. We will keep on noting down the remainders here. 2 16 the 32, remainder 0. 2 8 the 16, remainder 0. 2 4 the 8, remainder 0. 2 to the 4, remainder 0. 2 1 the 2, remainder 0. 2 0 the 0, remainder 1. So at the end till 0 you have to repeat this task. Now from bottom to top, so the answer will be 1, then 501. So this is your answer, 1501. Understood how we got it? Next is 122. Again you have to convert it into binary, decimal to binary. So we will divide it by 2 and note down all the remainders, and from bottom to top. So here you can see 2 6 the 12, 2 1 the 2, remainder 0. 2 3 the 6, 0 the 0, remainder 1. 2 15 the 30, remainder 0. 2 7 the 14, remainder 1. 2 3 the 6, remainder 1. 2 1 the 2, remainder 1. 2 0 the 0, remainder 1. So the answer is 41010. So you can see the answer here, 41010. Now there is one more method where you can check your answer. How you can check it? Like when you are asked to convert binary to decimal, we were writing 2 to the power 0, 2 to the power 1, 2 to the power 2. So this is 1, 2, 4, 8, 16, 32, 64. Now when you will add 64, only one you have to add, that is 64 plus 32 plus 16 plus 8 and plus 2, it is coming as 122. So my answer is correct. So whenever in exam you are solving it, you can cross check your answer. Now if you are asked to convert decimal to octal, we are dividing by 8, we are noting down the remainder, same from bottom to top. This will be your answer. The next question is 122. When you are dividing by 8, see the remainder is into 15, remainder is 2, 8 1 the 8, remainder is 7, 8 0 the 0, remainder is 1. So the answer will be 172 from bottom to top. Next is decimal to hexadecimal. You will divide it by 16, note down the remainders, and same way from bottom to top. Only the difference is if your remainder is more than 9. If it is 10, you will write A, 11B, 12C, and so on. Clear? So here the answer is from bottom to top 7A. So this is your decimal to any other number system. Now next topic is from any other number system to a decimal number system. So we are solving the next one. So in the next video we will solve this, that is conversion from other number system to decimal number system. So thank you. Have a nice day.